Hello, as I presented before, recently I'm struggling to get a high precision for the frequency measurement. It is not so high frequency, just around 1 MHz or the 2 MHz, but I want to make it very high accurate. Of course, if I have enough money to get to the regime oscillator, it's very expensive but very high accuracy. It has very high accuracy, but I don't have money and can't spend for it. And as I presented before, I changed my mind to get the high precision inside, not inside, but the external from the sky, from the GPS. And this is also, I say in the previous video, but the GPS module, Neo 6M can generate the very high accurate GPS trained clock up to actually 10 megahertz, not only the 1 hertz every second clock, but also up to 10 megahertz clock can be generated from the GPS module. And I made the breadboard version and it works very well, and this time I clean up to the single board version. And here is a result. As you see, it has a two SMA connector, and one is to the GPS antenna, and here is an input to the counter actually through the single gate buffer. And here's a buffer from here to the 80MHz 328 PD5 D5, and actually, as you see, it has a coin battery, and this coin battery keeping the configuration of Neo 6M. And also it has a two switch. The red switch can switch the connection between the UART. It has a CP2102N USB UART interface, and the connection between here to the GPS or the 80MHz 328 Arduino bootloader loaded microcontroller. And for switching connection to the GPS, we can get the positioning information getting from the GPS. Actually, I don't use for the frequency measurement, but we can see. And if I switch to the Arduino side, we can upload the Arduino sketch through the USB interface easily. We can improve the firmware as we wish. And here is the rotary encoder, which change the gating time. It's 3 sec and 0.1 sec. It's very fast. And also here is a yellow switch. Yellow switch can change the clock source from the GPS or onboard crystal. Currently, the clock is provided from the GPS to the 80MHz 328, but also we can switch to the onboard crystal. I will show later. Now let's see how it works. I already prepared another GPS module to get the 1 MHz to generate 1 MHz high precision signal. And let's connect to this counter. Yeah, it says around 1 MHz, and let's change more accurate mode, long gating term 9999, and also let's change to the 2 sec. Yeah, it has a very long digit accuracy, I believe. Yeah, and currently this counter is driven by the GPS, and let's switch to the onboard crystal. Now running from the onboard crystal, we will see small difference. Yeah, 0.189 or 184 around, and this means that this crystal has a small error, but relatively very high accurate, I think. Let's go back to the GPS version, the GPS clock. Yeah, it's 0. Now it's done. Have fun.